Hey everyone, sorry, Zoom's kind of flaky for me today.
No worries.
Can everyone see my screen?
Yep.
All right, cool. Let's run through the board. Got lots of stuff closed this sprint so far. Great job everyone on that. Like seeing the closed column piling up. Reviewing QA. So this is ready for review, Aaron, the sortition using recipient set?
Yeah.
Okay, I have not gotten to it yet, but I will try to do so this week.
Cool. Yeah, and there's I think there's already some comments and feedback on it. I know Ludo left some feedback, and so I need to address that as well.
Do you want to talk just a bit about this problem here that you were outlining?
Oh yeah, so this problem is sort of not addressed in the PR. Basically the issue is when you're evaluating whether a block commit should burn or transfer, you need to figure out whether or not it's a descendant of the anchor block.
Yes.
And the way that the PR currently does it is it just like steps back on parent block pointers until it is either at a height less than the anchor block or it's reached the anchor block. That is not a cheap operation.
No, it does not sound cheap.
And so, yeah, so that's sort of the problem, is like we need a data structure for performing that lookup. We'll probably do some sort of caching, which would alleviate it a little bit, but not entirely. And since these things are also just like arbitrary payloads on Bitcoin, without like minimums for participation and stuff like that, it's a potential DOS vector. So something that we need to think about going forward. And yeah, we can probably start a separate issue for it.
Would you be open to changing the the Bitcoin wire format?
Yeah.
Because we could do something. I think we have 1 byte left in the block commit structure. We could do something with it.
Interesting. Yeah. So like we could do something like, yeah, there's potentially things that could be done there. I agree.
Yeah, maybe there's a way we can free up like, I don't know, 3 more bytes or something, and you can just put the reward cycle ID directly in.
Yeah.
But
or just like
validation still wouldn't be cheap though.
Yeah. What we would want is something like almost like the like a pointer to the block in your fork at the anchor block's height.
Yeah, like an anchor block pointer of some kind, but that's still like, that's at least 6 bytes though.
Yes.
That's going to be a little bit harder to come by.
Right. But there might be some scheme where we can compress things. I don't know. There like might be a scheme there. So
pertaining to caching, I don't know if it's that hard to do potentially, right? Because you just build a map that grows linearly in the number of blocks that exist in the system, and you just map the block to its anchor block. So that way, like, you should be able to look up the block parent potentially and just do an all in RAM back walk to the anchor block. Stop after like 1,000 passes, because there's no possible way it could be longer.
Right. Yeah, I agree. The in-memory system could work out fine. We would want it to be somewhat efficient encoding, just because we might end up needing to store all of the blocks in memory.
At least some metadata for them, yeah.
Yeah.
But yeah, we can iterate more on this offline. I just thought maybe that would have been low hanging fruit here, but I guess not. Cool. I'll try to take a look this week, but my plate is pretty full this week, admittedly.
Yep.
Oh, this is the same thing, I guess, right here.
Yeah, I think that's just the linked PR or something.
Got it.
So for this previous issue that we were just talking about, Aaron, do you want to move that comment move that comment out into a new issue so we can keep track of it?
Yeah, I'll do exactly that.
All right. I sent the PR later last week that includes all of these issues. Let me see if I can find the actual PR here. I'm not sure it's tagged with a milestone. But there was a lot of feedback on it that I think maybe some points need to be unpacked. Let me just see if I can just go pull it up here. Mostly just concerned about how we want to proceed. Should I spend some time stripping out the delegation logic as a separate PR? No, this isn't it. Or do you guys want to take it over, or do you want me to stop what I'm working on right now and just push this over the finish line? I'm not sure what the best approach is right now.
I think that separating delegation out of this PR would be good to do, just because I think that we probably want to spend some more time going back and forth on delegation than the rest of the PR. Like the rest of the PR seems much closer to consensus than the delegation. So separating them is probably beneficial.
Okay. There was one general POX design question I had though, and I think it's like towards the middle of this giant comment stream here.
Oh yeah.
Yeah, it was, I did not understand, or not understand it. I didn't comprehend correctly this particular line in SIP 007.
Right.
And I was really confused by Jeff's comments as well as a result, about there somehow being multiple tiers and something dynamic about the stacking limit. And I'm like, what are you talking about? It goes from 25% to 100% as a step function, but that of course is not correct.
Right.
The reason I assumed that was the case is because I think that making it a dynamically adjustable value is actually a bad thing, because it rewards people for not stacking honestly, which can lead to very strange, potentially chain degrading games that miners and stackers can play, like where miners play a game of chicken, just wait until the last possible minute to stack because it means they can get more reward cycle. They can get more reward cycle slots for the same amount of stacks, which they want to do because that maximizes their payoff. And in order to do that, though, they have to somehow, what it fundamentally does is it makes the worth of the final transactions, of the last N transactions for N stackers in a reward cycle really, really valuable. Like more valuable than the pricing model for a transaction fee would otherwise imply. Because if you can get, if you can be the last possible stacker in a reward cycle, then you can know for certain like that you will not be outpriced out of a reward cycle, and you can make the best possible economic prediction. Because right now, if the minimum stacking threshold can increase, let's say for example it's currently 10,000 stacks, and I lock up 10,001 stacks, but then Aaron stacks, and now the minimum stacking threshold goes to 20,000 stacks. Well, I've just locked up my stacks, but I can't spend them for as many reward cycles I locked them for, and I'm not even getting any reward cycle out of that.
Right.
So that's a very bad problem. Like that's costing me opportunity as well as transaction fees. So I want to avoid that to a very, very large extent, up to potentially bribing miners to to conditionally mine my transaction on whether or not it will actually get a reward cycle. Like I could share my prospectus here, like my potential payout from stacking with miners, and that would be a profitable move for both me and miners.
To a certain extent, I think that that's the case, but also like if you are a large enough stacker, movement in this threshold is basically the difference between you claiming 6 reward spots versus 7.
I mean, sure. I agree that the marginal utility goes to zero.
Yeah.
The marginal value of the n plus first reward cycle is not that big compared to the nth, compared to like when n is large.
No.
But I don't think that's the majority of stackers. I think the majority of stackers are going to be 0 or 1 reward cycles, just because the distribution of stacks is kind of like this long tail. Especially problematic for delegators who are going to be trusted with like stacking at the right time on behalf of potentially many small stackers.
Right. The alternative without dynamic payouts is a system in which anybody who would have lost out would not be able to stack at all.
But at least your stacks aren't locked for the next, let's say, 12 reward cycles, and you're getting nothing for it.
Yeah, that's true. But I think that that's like a detail that's like potentially solvable with like automatic unlocks.
Yeah, we're gonna have to. The fundamental problem is that like this sort of falling through the cracks scenario can't be allowed to happen. Like I have to be able to get my stacks back if I tried to lock and it failed.
Yeah.
Either that or I have to know a priori guaranteed that the minimum stacking threshold is X, and then I can then choose to stack or not stack. And then a rational actor would just not stack if they can't meet the threshold for even a single reward slot.
Yeah. So I think that this this discussion is important and that we should probably be having it in like its sort of own forum.
Yeah, I agree. Like we're not going to solve it here.
Yeah.
I'm just bringing it to attention because I think it answers the question about whether or not we can even get just the POX lockup over the finish line.
Right.
Because I'm not sure this particular issue is close to being solved, especially now that we're this late in the game.
Well, I think we can probably do either a static scheme or one that doesn't have some of these dynamic elements. I think it's still useful to test the rest of the end-to-end mechanics of POX while we continue to debate this in a public forum and refine this, between now and in phase 4.
But Walker, this does it. Whether or not I don't know what to do. We have no course of action to get this merged until we know what we're going to go with.
Well, we could merge a static cutoff for stacking with like a definite plan to revisit.
Is that a plan that everyone's happy with? Like,
yeah.
To be able to test the stacking, the faucet will need to change too, because currently the amounts that you can get from faucets are like way off from what you need for stacking. And you could even start with stacking only like 100,000 and have no function that would still test a lot of things.
Yeah, exactly.
Yeah. Yeah, I think that's true. That the faucet needs to update a little bit, but all that's doable.
Or you need to statically allocate a few addresses that people pre-register before we start the phase or something.
Yeah, I mean, it depends on what the total liquid stacks in testnet is defined as anyways.
That's true.
I think it starts at 0 in testnet.
Yeah.
It really is just, actually, no, wait, it's the sum of all initial balances.
Yeah.
Which is kind of big. Like the amount you getting stacks through mining is going to take you a while to even get to like 1/5,000 or 1/20,000. Like I think we have like like 1 million stacks in the faucet or something like that. I don't know off the top of my head. I'm gonna have to.
Well, there's 4 addresses with 1 million, I think.
Yeah, and stacking and mining only gives you 500 stacks per block. So getting to 1/20,000th of a million. I mean, I guess you could mine a few blocks to do that. I don't know, I'm just trying to do the math in my head and I'm not.
Oh, 1/1000th of a million is 1,000.
Yeah.
So
The 1/20,000th is, yeah.
It's still a lot of blocks.
Yeah, it's like 500 blocks or something.
400.
And that's to get to the minimum.
yeah. So I mean, we can decrease the amount of stacks that we're sending to those addresses. Like we can make this easier. Like we can make it so that there's a bunch of people in the community able to stack in testnet. And then you might want to tag Ludo on that because Ludo's working on the getting the testnet set up.
Good point. I can open a separate issue for that too. So this is an action item. I just want to make sure we don't drop this. What would be a good forum to discuss the design of POX further, both in the delegation aspect and in the static versus dynamic minimum threshold increase?
Well, I would say that they should be treated separately. Like they should be entirely separate posts or whatever. But like, I don't know, GitHub issue. Like if we want to do it publicly, it's GitHub issue, I think is the best.
Yeah, I think we can make a GitHub issue and we can post it on Discord as well. And depending on how the discussion is going on the GitHub issues, like if it feels like we can get to some convergence asynchronously, fine. But if it feels like we're just kind of going around in circles and we actually need to put people together in a room, then we can schedule sort of a call similar to this one, open it to the community, or maybe just reuse this one next week to get some of the decisions locked down.
Yeah.
Sorry, I'm just turning the PC off in here. It's too loud. Can you say that last part again, please?
Is it really a group decision that you need, or is it more like a game theory analysis where it's like, is it at all even possible to have to enter into a cycle and not know what that limit's going to be and not have some way to front run? Like, I don't know if that's true or not, or false. Kind of like going back to what you said.
Well, like I said earlier, like the fundamental issue is we need people to stack honestly. So you stack the amount that you want to stack, that you intend to stack, like whether or not it's public knowledge or not should have no bearing on whether or not you take the action. Because the problem right now is it's not true. And that means that there's a bunch of games you can play that disrupt the chain quality in an effort for you to get the highest maximum payout for stacking. There's a couple solutions to this, but they have other non-trivial implications as well. Just to summarize, the two big ones are we don't make it dynamic minimum stacking. And the other one is we make it so that if you try to lock your stacks, they unlock automatically if you don't get a single reward address. I'm less certain about that second one because as mentioned elsewhere in that forum, in the pull request, we need to bound the number of distinct stackers per reward cycle. Otherwise it opens a pretty bad DDoS vector.
Yep. Yeah, it sounds like you're on top of it. I think I'm just like, I'm vaguely aware of the issue. So it sounded like something that's more sort of research based, but yeah, I'm good.
All right, so I guess we're good here. We can move on to other issues. I mean, all of these aspects here of mine are part of that PR. So statuses, we'll follow up on that POX PR. And I guess our action item is leave it static for now and swap delegation out.
Yeah, I think there's a couple other PRs in review currently.
That's weird, but they're not on I guess they're not tagged.
Yeah, they might not be tagged with the milestone. I know Pascal has a couple open PRs, I think, waiting on sort of the next round of feedback.
Yeah, I saw those. I'm trying to get those done this week too. But just finishing up this milestone, we'll get to those shortly.
Cool.
So in progress, crash after opened try file storage. Aaron, I know that you diagnosed the issue here.
Yeah, I'm still working on it. Yeah, basically the question was just like how horrible of a refactor we wanted to go through here. And I think that I found like an in-betweener, which will be a little bit easier, or require less lines of code changed, but is like slightly less type perfect, I guess. So basically the thing that I'm doing is like in the marf try file storage struct, I added like a connection object, which is just like a handle to the try file storage, so that the index db_tx struct can like hold a single handle, which is a connection to the try storage, which also is a connection to its SQLite instance. And that way the same transaction can handle both the marf writes and the side store writes. This is really easy to do if you implement it with derefs, but you don't get, like, the type system isn't enforcing that you're always using a transaction versus a connection object.
Right, that's the next question. Like, how do we ensure like you don't have a separate transaction open somewhere else?
Well, it would panic. Like you're going to, like, the SQLite library won't let you do that. Okay. So the question is, do we want panics or type checks? And like usually you want type checks, but it's probably the difference of like 3,000 lines of code. So because it would basically be all of the SQL, like almost all of the marf storage functions would need to be rewritten.
Yeah, okay. Maybe we can just put that in the back burner then.
Yeah, so I think like we'll have panics for now, and then just like put a pin in it and say like this really could be enforced by a type checker. But
I think we will eventually want that, but we don't have to block mainnet over it.
Yeah.
You want to just open an issue just for that?
Sure.
Cool. All right, I just opened this issue. This is just where I'm at right now in POX. I think most of the, I think the blast radius for refactoring the networking stack to deal with POX and block synchronization is limited to 2 areas, thankfully. The first of which is making it so that the preamble doesn't deal with consensus hashes anymore, and that's pretty straightforward and easy to do. Second half that I'm currently working through is I think we can just restructure the inventory synchronization logic and not have to touch anything else. Like, that was actually unknown to me. Just make it so the inventory synchronization logic just knows how to deal with the case where the local POX bit vector has a 0 for reward cycle C, but some other neighbor has a 1. Because that seems to be, that's the only case where where it would be true that some other neighbor potentially has a missing anchor block that this node does not know about. That does require restructuring some parts of the block synchronization logic, the inventory synchronization logic. We do have to make like a per node state machine now, as opposed to a global singleton state machine for inventory synchronization, but that's not too terrible. There's also some interesting malicious behaviors that nodes can exhibit that I need to test through, like a node lying about the presence of an anchor block when one does not exist. And that needs to percolate into the inventory system deciding that neighbor is broken. I think all this is doable. I think it's just a matter of getting it done and testing it. my current intuition and understanding of the blast radius is just that. It's just an intuition. It needs to be tested out and proven. I'm hopeful that it doesn't have to touch any other pieces of code. I hope to get a PR out for that sometime this week. Preferably early. Backlog. Argon node immediately crashes. Is this the same issue, Aaron, the MARF?
I'm pretty sure it's the same issue.
It looks like it, because I think there's a discussion either here or elsewhere about it. Yeah, I think you commented at the very bottom here. Yeah.
Yeah.
Cool. Alrighty, clearing the milestone. All right, first of Pascal's PRs. Implement square root integer. Cool. So, Pascal, do you want to speak a little bit more about this PR?
The reason why or how I implemented it?
Oh, both. Just anything that you feel needs to be said.
Well, square root is something that I need for Swapper. And in Clarity, there's a way that this is some libraries that you can use, but you need to iterate. Mm-hmm. So implementing that in Clarity would be in Clarity would be pretty tricky. Even though there are some ways maybe to do that, just implementing it's just a lot more straightforward. And luckily, I found a crate that implements the algorithm that you can find mostly for the basic square root that implements that with integers. So that's this full precision all the way to max 128 bits.
Cool.
So yeah, that was actually fairly straightforward.
Yeah. Yeah, so I think like a related issue to this, and then like some of the discussion on the stacking PR that like yes, Ludo had brought up about looping. It's like, it's not essential to Clarity that there be no looping whatsoever. It's that the loops have to be static. And like right now, we don't have a nice way to represent that. Like we can just map over a like list that you type 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or whatever.
Because the algorithm is bounded in based on the number of bits, so that could be done, but that's still a lot easier to have a native function, and it's going to be a lot faster.
Yeah, I think we probably should have this native function.
Because the complexity is pretty much about the same as the power function, the POW, which I include a small fix in. That was something that was lingering, since it was like basically the same kind of code. I just put that in as well.
Yeah.
And there are some algorithms that I found that they use actually in microcontrollers for hardware, or FPGAs to implement the square root, but it still would be like a pretty messy algorithm and end up being very costly.
Sure. But we may want to add like a for loop function to Clarity in any case. Like a for loop that just like, it gives you binds a variable I, and it has,
that would open up a lot of other things that you can't do.
Right. I mean, I think that it wouldn't like strictly enable you to do anything new, but it could make a lot of things much nicer.
I would love to see that myself.
Yeah.
Because the POX code has at least one horrible instance of abusing map and fold to do basically this.
Yeah.
Yeah, I've seen a few examples.
Yeah.
As well, but
Pascal, just so you know, one of the review rules that we enforce when it comes to PRs is that if you bring in new crates, we tend to audit the crate too. And If the crate-
I realized that, and I looked at it. It's fairly straightforward. There's like a few hundred lines.
That's good. In
So
fact,
that's why I didn't have any. Otherwise, I would have re-implemented it.
yeah, you're on the same page then. Because what I was going to suggest is if it's a complex crate, we might just vendor the parts that we care about.
Right. No, the algorithm is fairly straightforward. I mean, if you'd rather, I can just re-implement it. But it was the one reason I would maybe re-implement it. It's because it's actually including code for other. Maybe the compiler will strip it for like 16, 32, 64, and 128, and we only need the 128 bits version. I would think the compiler is going to strip it, so it's not going to bloat the code.
Yeah, the compiler should do that.
Right. So, but
It's
yeah,
also-
that I know, and I know I upgraded the SecP 256K1 crate as well. This I have not reviewed the code, but I'm assuming that a lot of people have. And maybe we should anyway, but
I have looked up the SecP256 library. It's Peter Wheel's work. I know that it's the same exact library that Bitcoin uses.
right, yeah, that's why I think we're safe in that case. And as I was doing that, actually, there was a new version released because I thought it was 17.2, and suddenly there's 19.0 that started propping up.
Yeah,
I was looking for docs, so. But this like it was just a straight recompiling that worked. There was no API changes that at least the code depends on.
Mm-hmm. No, yeah, like that sort of thing is totally fine too, for the reason you point out. Like Bitcoin uses it, therefore it's probably fine.
Yeah, but in that case, the crate is really tiny, so and there's no extra dependencies from that crate.
That was my second point. Good to know that too.
Yeah.
Cool. I will try to take a look at this week. Just depends on how soon I can get the POX code shipped as well, though.
Sure. Yeah.
Thanks for sending it. I really appreciate you taking the time to add new Clarity features that turns out we actually do need, but wouldn't have known otherwise.
Yeah, because I was reading yet another paper on automatic market makers, like a full generalization of Swapper, and Swapper version 2 uses square root to start the balance. Especially it's important if the two coins are very off balance, like you've got 1,000,000 to 1 value. Mm-hmm. So you actually use the square root of 1,000,000 times 1 or whatever the value is to get like something that is in the middle. Otherwise you can have like drifts. And the paper I was reading was actually like when you take the general case and you simplify the square root also, it gets there. There's like there's a reason for that madness. So, yeah. So that was the little thing that put me over the edge and say, okay, all right. And that wasn't too much of a stretch to do. So there you have it.
Awesome. Aaron, I see that you discovered a bug in AtBlock.
Yeah, I'd actually thought that this was possibly existent for like a couple weeks. I don't know. I don't know how long I've thought this was possibly existent, but it occurred to me I needed to actually produce an issue for this. And there's a test that exhibits the behavior. So basically the problem is it's an interaction between AtBlock and the key value wrapper struct. Mm-hmm. Which is what implements like the Clarity transactional rollbacks. So basically, if you initiate an AtBlock construct, it does not, like it continues to query through that key value wrapper.
I see. So you see values that aren't committed yet, but are written.
Right. Yeah.
But this is consensus critical, so we can't just ship a fix right now to master.
Correct. I mean, like maybe we could. That's like a question for what contracts have been deployed, right. Like whether or not any of the contracts that have been deployed exhibit this bug. But yeah, a fix for this should probably be open to get next.
All right. I'm just gonna add that here then. We'll just ship it when Krypton ships.
Well, someone would need to implement the fix first.
That too. Update DNS to use.org records. I think this is on Ludo's plate.
Yeah, it's a small fix in the config.
All right, cool. Jeff, are you on the call still?
Yeah, I'm here.
Cool. Do you just want to talk a little bit more about the rationale here? I don't have all the insight into the user experience side of things,
Yeah.
but I really appreciate where this is coming from.
Yeah, sure. I think the first thing I did was just comment that I think I'm just using sloppy language here. So what I really mean is that in a stacking transaction, the ability to specify the number of reward cycles that you want to lock for.
Mm-hmm.
I'm assuming that we still support that in some form. I don't know what the upper bound is. Is that still right?
Yeah.
Oh yeah, it's 12. You can do up to 12 reward cycles.
Got it. Okay, cool. So yeah, I was around for those early conversations. So that was my understanding. And what I was saying is that I guess the real root of this is like I wanted to know what the state of this decision to potentially do one Bitcoin payment per block. I know that was discussed at some point, because if we do make that change, then I think it changes my calculus about the time ranges, like 12 versus 5 versus, whatever. So I guess that I was suggesting that if we do if we decided to go with one payment per block, then I'd suggest this additional change to how we think about the amount of cycles.
You lost me at one payment per block. I'm not sure what that means.
Did you guys discuss that at all? Has that been discussed?
Yeah. So it's like the number of proof of transfer outputs per miner commitment, right? Like right now it's 5. But if we wanted to change that to 1 to reduce the barrier to entry for Bitcoin TX fees, we would, in order to maintain the same reward set size, we would need to do a 5,000 length reward cycle.
Yes.
Which also changes the calculus about the 12 reward cycle maximum, because now that's not 12 weeks, that's now like 12 months.
Yes, it is.
Yeah. So I think that we can kind of punt on this particular question. I just am curious like what the disposition of that first decision was, which is like, why not switch to one output per block?
So if I remember correctly, the fundamental problem with trying to add a lot of burnout of these payment outputs to a transaction, like more than one specifically, is that the transaction gets bigger, and as a result, the fee gets higher. And as a result of that, 2 bad things happen. The first bad thing is it prices out small miners, and the second bad thing is that it can potentially price out mining altogether. Like if the Bitcoin fee is higher than the Stacks reward in terms of monetary worth, then no one would ever mine. I think we've addressed the second problem. The second problem is that the solution to the second problem is that if you don't mine in a Bitcoin block, but you do mine in the next one, you just get the Coinbase rolled over from the block that was not mined.
Yeah, I saw that somewhere. That makes sense. I think the reason it stuck with me as like a change we should consider is less of a less the scenario you just described, and more just like the economics being less favorable, just based on the amount of basically what I think is like in the years ahead, there's just going to be this great battle for sort of yield on assets, and so I'm just trying to think of ways to make the upside better for all the stackers, basically.
Yeah. So over a long view, decreasing the number of outputs slightly reduces the yield for stackers, because there's a couple outputs, or there's one output and like the inputs. There's like some TX size which is fixed no matter how many of these outputs you have. And that's in some sense getting like amortized the more stacking outputs that you have.
Because I looked at the Bitcoin transaction, currently it's 318 bytes. Adding 4 addresses, that adds 136, so 30% of your transaction size.
Yeah.
So I don't think it's that bad,
Right.
at least currently. Even at the highest fees that we've had lately, they would still allow 7 miners. The fee would have to be like 5x.
That could happen.
That could
Right.
happen. It's you're looking at ETH. ETH is like going totally crazy, but
yeah. So I think that like ultimately just changing the number of outputs really just changes the like it changes the scale of the problem, but it doesn't really address the problem of like TX fees spiking.
Yeah.
And then on top of that, if we actually reduce it all the way down to 1 output, it introduces potentially a separate problem, which is that if you're doing discount mining, you actually just get a free block every time your address comes up.
Yeah.
Like you're basically just guaranteed a win for free.
Yeah.
There's also user experience implications. I don't know, Jeff, how much of a consideration this is, but I think in the original discussions, like we had talked about, like there's some like nice properties of having like this 1 week where if you're a stacker, like you get, it's not like instant gratification, but you feel like there is reasonable feedback relatively quickly. If people are going to be, waiting for 5 weeks, I think, there is some product implications there, like how many people would kind of just get dejected and walk away. Or just lose interest because they're not seeing anything happen for 5 weeks.
Yeah, I suppose that's true. I think it's I don't know all the angles to like the perception sort of qualities here. It's also like I think for a very very large stacker, this all kind of becomes negligible. But for a smaller stacker, I would imagine it's like that you're paying that 30% higher amount of fee than you would otherwise, and you might want to rapidly exit to sell or whatever. Like it's like the utility of being able to move your stacks versus the known sort of waste that you're incurring. Like I don't know how that sort of nets out for people.
There's we do have delegation as an option, but it's still pretty underspecified. If we could find a way to make that process really smooth, I think that would alleviate a lot of these concerns, because then you could have 1,000 stackers pool together and become effectively a large stacker, at which point this problem becomes less important.
Yeah, that's true. I'm not certain this is a great idea. I just didn't want us to kind of dismiss it without taking a serious look at it, because my sense was is that I do think the fees are going to get a lot higher in Bitcoin over time, and so I kind of worry that could be, it's like could just turn into a big problem. So I'm interested in like ways to fix that problem.
If it is the case that fees A, get really high, and B, there's a huge market interest in yield-based systems like this, what we can expect to see, I think, is Bitcoin miners themselves will start to do things like stop people from even mining. Like just Bitcoin miners and only Bitcoin miners will be allowed to send block commit transactions. Like there's other sorts of weird shenanigans that start to happen once there's money to be made by delaying or reordering or even censoring transactions from the Bitcoin mempool when it comes to putting them into Bitcoin blocks.
Yep.
And that's a dark forest, quote unquote. Like that, it's hard to know what exactly is going to happen here. And the act of even identifying yourself as a new player in the space or as a potential money-making system is really just the act of you alerting everyone else who could take that away from you and who will do so.
But the challenge for stack mining is that if you try to play with a fee, you're going to get in too late, and the blocks you're going to generate are going to be rejected. So you need to pay the minimum fee to get into the next block.
Yeah,
which you can pretty much fairly easily determine. But the Bitcoin mempool, it's not overly, at least over the past few weeks, hasn't been crazy. ETH is like the 150,000 transactions and a lot of junk in there. That a lot of transactions that keep getting added for for with a transaction fee, there's no way at the current price is going to be there. So they stuff sitting in the mempool for weeks because they don't have any trimming apparently, or at least not for weeks.
Yeah.
So, but that could happen the same way to Bitcoin.
Yeah, it could. And moreover, even determining the min fee for inclusion is itself a difficult problem, because there are services now where you can pay off-chain a miner to get your transaction included. So the on-chain metrics for fees are actually not informative.
Well, but you can still analyze the past blocks and see what the fees were.
But that's the thing, though. Like if I pay,
there's additional fees that you don't see in the block. You mean?
That's already happening. Like there are. I think Blockstream will actually let you do this. Like you just Venmo them money or something, and like say, hey, make sure this transaction gets mined. I didn't set a high enough Bitcoin fee, so here's some dollars. Please mine it for me.
Yeah, but you still need to pay all the different pools, though. It's not that easy unless there are services that.
Yeah, you would
aggregate the pools and
you're working in. Like it doesn't have to work all the time. It just has to work enough to make it profitable to do so. It's a hard problem. Like I don't think we're going to be able to solve it in this call.
No.
But I think the best we can do is like just keep working and thinking about it. What we can at least do, like replace by fee when mining in order to bump your transactions up in priority. So even if you don't have access to the off-chain payment networks that exist, at least you can pay them on-chain. And Bitcoin does have a replace by fee that we can use.
Yeah, I guess even during the current block, because my biggest worry is that if your commit doesn't get into the next block, then that commit is junk. And there's no replacement fee that you can pay that's going to make it valuable for the next block.
Yeah, that's a separate question. Like I almost wonder if it's worth exploring this possibility of making it so that block commits could somehow be valuable even if they're late.
Yeah, and it's a particularly, I think, like horrifying concern if you think about Bitcoin miners participating as Stacks miners.
Yeah, if Bitcoin miners start to participate, we turn into a merge mined chain with 100% participation is really what happens here. Because what Bitcoin miners can do is they can unilaterally agree to say, hey, every Stacks block commit transaction is censored except for the one that I send. And therefore
but you don't need unilateral agreement.
Well, sure, like you don't, and that could happen. Like Antpool tomorrow could just decide, like, I'm gonna block all block commits except for the one that I send, and then all Antpool blocks just have one block commit, and it's Antpool's block commit.
No, but like you don't even need to be a major pool, right? Any winner of a Bitcoin block who is also a Stacks miner can guarantee that they're winning that Stacks block.
Yes, they can, and I expect that to happen at some point.
Right.
And that's why I said, like, this is like as if the chain was a merged mine chain, because the only people who get block rewards at that point are the miners themselves, the Bitcoin miners.
Yeah.
I almost wonder, though, if this game alters the calculus a bit for user burn supports. Maybe they'd censor those too because they can snipe parts of the coin base. In fact, yeah, they almost certainly will.
So it would be good to get to some closure on this discussion. Jeff, like, do you feel like you're seeking sort of more discussion or more change, or is the sort of the current setup of 5 addresses is good enough and we don't need to revisit? Like, where do people stand on this?
I think it's good enough as a default. I think I'm actually more interested in like an analysis of maybe like there's like the relative answer in a percentage based sort of setup, and then there's also just like what amount of money are we talking about if the Bitcoin fees go really high? Because people might kind of think like resent the system just because it's like lossy and like look for places where they don't have to waste so much valuable Bitcoin in order to participate in a mechanism, you know? So I think that's, I'm kind of curious almost to see like Jesse's table that he created, like blown out with some higher fees or something. Like, I think that's maybe the next step.
Okay.
I can ask him about that.
I've been keeping track of the fees, and on August 25th, it would cost you $5 to mine a Stacks blocks.
Back in 2017, Pascal, when we were operating a free on-chain name registrar, it could take north of $60 to get our transactions in.
Right, and that's gotten better because a few weeks ago the fee would have been 2 or 3 times more than that. The fees have come down
Mm-hmm.
because
But
the fees are around 100 Satoshi per byte, but they've been like lately over 200. But yeah, there was a time where it was like totally crazy. I know.
We
Yeah.
can close. We actually probably close this, or sorry, not this ticket, but the one that I was pointing to before. We can actually close it because it seems like there's a decision to make first, and then that I can reopen that one later. But the main decision is just what is the best sort of mix of trade-offs for cycle length, and I can just chat with Jesse and sort of have that discussion in a new ticket. I think that's the best solution.
All right, sounds good. Jeff, do you have any comments on this one here, stacking limit changes?
I think it is. I think this ticket or this decision is kind of bound up in the discussion you were having earlier. Does that make sense?
Just related then.
Yeah, it can be a kind of icebox and still then, or related or whatever. Yeah.
Alrighty. Here's the other PR we got, bumping SecP256K1 to the latest version. Thanks for doing that, Pascal. Appreciate it.
And it also implemented the recover and verify function in Clarity.
Yeah, we're going to really need that before mainnet, so it's really awesome that this is working here.
There was one change that I made based on Ludo's, compared to Ludo's original suggestion, which was I added a principal of, because it recovers the public key, not the principal, because otherwise you can't feed that public key into verify, for example, because there's no way to go back from a principal to a public key that is needed for the verify or the recover.
That's a good point. We don't really have a principal constructor anywhere.
So, but that principal of from the public key is really just usable for this because there's nowhere else in Clarity where you have this. But it's definitely something you can feed directly from what you get from the SecP functions.
Is there a reason principal of can fail? I see that it has a response type here.
I should have removed that. I think there's still one path where it can fail, but no, the Clarity function cannot fail. It can panic, but it cannot not panic, but. No, it cannot fail. I need to change that. And I think I changed that in the code, but maybe not in the API.
Wait, my understanding was that not all 32-byte buffers are valid.
That's correct. Not all 32-byte buffers are public keys.
SecP256. Yeah, so you would expect that in fact to be a failable function.
I need to go back to the code because
I guess
there might be a few question marks left in the code where it could return an error, yes. But then the whole function would fail. But you cannot control that from Clarity. It's just
I think
transaction would fail.
Yeah, I think that this is probably a good discussion for review on the PR.
Okay.
Yeah, I started with a response type, but I think I most of the code looks fine. But yeah, there are. If you just randomize a public key, which is not that helpful, that could make it fail. Yeah. But at least your transaction would fail. But if it's a key that's been derived from a valid private key, then that shouldn't fail.
Right.
Because the generation of the private key iterates till it finds a valid one.
Yes.
Which I think is why I can't remember because I was like a few. I went back and forth quite a few times. But I think if it fails, then the transaction fails, and then that's because you gave it some junk anyway.
Yeah, I think that's generally speaking correct that that principle of should fail, because like the 33 byte value you're getting is like a compressed representation of an XY pair on the SecVQXXK1 curve, and not all such 64 byte values are XY pairs. So it should fail in that particular case. But you're right, it can't really show up if you're using it in conjunction with the recover function, because you will get back a valid public key in that case. But if I just gave you a bare buff 33, like
Right, yeah. I mean, I can add back because I think I had started with that and then I removed it. But I can add back a response type if we think that's better, so you can control it from Clarity instead of just failing your whole transaction.
Yeah. Do we have any more insight into this issue here with the slow response endpoints, or are we just waiting to duplicate it on the current testnet instance? Because the only thing I saw from the log file here was just that the P2P thread wasn't really doing anything. But I guess we're just waiting for the testnet to get close to restarting.
Yeah.
I mean, at the current block interval, I don't think
we might not get there.
These testnet heights. So I think once we wrap up some of the functional PRs and we have time to devote to performance debugging, like we'll have to try and reproduce this locally. That's probably going to be the best bet.
Okay. Sorry. So I'll just make a comment to do that. That probably won't be for a while. Alrighty, mind block command. So I know that I know that the node can currently mind blocks, and I know that there's like a slew of issues related to making a block template that in turn can be mined. Would you want to comment a bit more about what you envision here, Pascal?
Well, because Marvin had the same issue. If your Clarity function rely on long-term things to do different things. For example, I needed like 1,000 blocks to be able to trigger something. If you test it using the Clarity SDK, there's no way to do that. So to be able to test it, just relax the function value, not the function, but the number of blocks in the code.
Okay.
But to be able to test like 1,000 blocks, because the geyser that I had for Flexer, every 1,000 blocks that you've locked, you get a higher reward. So up to 3x after you've locked for 2,000 blocks. So at that I couldn't test. And that's something that used to be, there used to be a function that was removed that was never implemented in the Clarity bin client.
Yeah,
the Clarity SDK actually still calls that, but it doesn't. It finds no one home there.
Yeah, I think that mind block function wasn't. Yeah, it wasn't like wired up to the block database that the Clarity CLI or the Clarity bin was actually using for evaluation. Which is why I think it was removed. But yeah, a function like this for simulating just moving a block forward is probably useful.
And I mean, you could just like iterate and send the same transaction over and over that does nothing. That would still mine the block.
Yeah.
But
yeah, it would be easier just to add the the CLI.
I don't think that would be too complicated to.
No, I think it would probably be about 80 lines of code. So we could probably just label this as like a good first issue or something and see if someone can take it.
Oops. Yeah, that's a good idea. All right, I think we're at the end of the cycle here. Cool.
But there's still need feedback and another PR too.
Yeah, there's like a fix for the trade PR,
The
right?
trade PR to be able to, when you add it to the mempool.
Yeah.
Sorry, I'm just being it slow right now. What state is that PR in right now?
This was already one round of feedback.
Okay.
Because I added because I wasn't testing that the principle you were passing implemented the traits. I added that.
Okay.
Because otherwise it would just repeatedly fail. I don't know what else would be needed.
Aaron,
there was a discussion from some comments from Ludo as well, where it was.
Yeah, I think this is just waiting on the next iteration of reviews, and then
Right. Yeah.
should be. Yeah, I'll take a look at this after the meeting, and
Sure.
yeah. Ludo, do you want to take another look at it as well?
Sure. Yeah.
Cool. And then should be able to review this pretty quickly. So.
Cool. How are we doing on the test net? I know that we're slightly over time, so apologies about this. Nothing seems to be broken on the test net, right? Can I just check this off?
Yep, I think that's fine.
Cool. Test net timelines and estimates. Well, this is just going to be just another round of adjustments. I'm just going to say that up front right now.
I don't think we need to use this doc. I mean, given where we are, I think it's probably better to work off like the actual known outstanding issues that we have. And, you know, we just ran through the board. Everyone knows what everyone else is working on. I would say, you know, Jude, you have a lot on your plate that I feel like is currently sort of on the path to getting the testnet live. So if anything, like we should take a few minutes to talk about like, are there things that other people can take off your plate? You know, do you want Aaron or Lulu to help out with the stacking PR so you can focus on the networking one, or some such, you know, other options there?
I feel like that latter option is probably the safest course of action, just because I'm already like, I don't know, 1,000 lines into the networking changes.
Yeah.
And I think that all of the feedback on the proof of transfer PR, except for the unresolved issues, are pretty actionable right now.
All right. So then in that case, I would say, since Aaron is also working on the MARF issue, I would say maybe Ludo, if you want to take over the stacking PR, and then Jude focuses on the networking PR, Aaron can focus on fixing the MARF bug and any other kind of other issues that come up.
Does that work for everyone?
Sure.
Thanks, Ludo. I really appreciate it. I'm sorry I have to drop this in your plate on your lap.
That's fine.
All right.
I volunteer.
All right, cool. Is there anything else anyone wants to talk about?
I started looking at implementing 1615, which is removing or adding the possibility of not reusing the same key registration.
Mm-hmm.
It looks like, at least with the code, just removing the test might just be enough. But I was wondering though, if maybe we could have like a key registration needed every 1,000 block or something to match the reward cycle or something, so miners can keep.
They're forced to renew it.
Right, yeah, or something like this. Not every block, but at least every 1,000 blocks maybe, or some other function. So
I think that we should default to not having that unless we come up with
that would be simpler, but it's just an idea that maybe something that makes sure that the miners stay fresh, or if I don't know, there may not be a reason to do that other than forcing them.
Yeah, I think we convinced ourselves that there's no downside risk in just doing it forever, except for when the key gets compromised. But at which point, the only person who's hurt by that is the miner.
The miner, they can decide to use a new one now because someone else is using their key. Yeah. That would make it simpler anyway.
Yeah. Yeah, I think it's just a matter of removing the test and then removing the tests in the test battery that verify.
Right, yeah. At least I started looking at it last night. That's so far it looks fairly straightforward.
Yeah, I think there's also like a MARF key that needs to not be set anymore in this Audition DB, but that's, I think, maybe the only other.
I think you still need to keep the Marv key, but the
Oh,
status,
right.
the status doesn't need to be updated to use or something like this.
Yeah, that's right, because we don't want key reuse, but we will want, yeah.
Yeah, we still need.
You still need to make sure the key has been registered.
Yes, that's true.
So yeah. So anyway, that's what I'm working on next. Besides just working on feedback, unless there's something else that needs help with. But
I know that sounds awesome. That's going to make the user experience, I think, especially with regards to fees, a lot better. As you said earlier, like 40% reduction in fees. That's going to be
right, yeah.
Right.
All right, we're way over time, so I would say let's wrap up.
Yeah, we're 10 minutes over now. All right, thanks everyone.
Yep.
All right.
So.
Bye.
Adios.